Hey everyone, welcome to your first flip class video. Today we are going to learn about slopes of parallel and perpendicular lines so that we can identify lines that are parallel or perpendicular. You'll know you've got it when you can pick a line or point that creates a line parallel or perpendicular to a given line. So first, let's do a little reminder of what slope is. So hopefully you remember that slope can be described as rise over run. And we're going to find the slopes of these different lines here. So this line that I'm coloring in blue, I want to pick two clear points on it. So you want to pick a point where the line goes through those grids nice and cleanly. Sometimes on a test you might need to pick points that are going through that grid nice and cleanly. So this blue line, since it's rising up to the right, it has a positive slope. And if I count the rise over the run, I get 1, 2, 3, 4, 5, 6, 1, 2. So this slope is 6 over 2, which is equal to 3. Alright, now we're going to look at this line, so I'm going to color it green. And again, we need to pick some points that go through the grid nice and cleanly. So when our line is rising to the left, or going down to the right, it is a negative slope. And if we count the rise over the run, then we get a negative slope of negative 4 over 6, which equals negative 2/3 if you simplify. Alright, next we're going to look at this line that's going up and down, so our vertical line. Vertical lines have undefined slopes. And then last but not least, our horizontal line here, that light purple, has a 0 slope. Alright, so we are going to keep this in mind while we look for the slopes of the lines in these examples below. So first we're going to look at these two and figure something out about those lines. So first let's find the slopes. So line CD, that's how you can write line, by putting just a little line over the letters. We count the rise over the run. I get a slope of negative 3/2. And then same thing, let's find the slope of AB. So I count my rise over my run is negative 4 over 2, which simplifies to negative 2. Let's take a look at this one before we talk more about the lines. So if we find the slope of AB over here, doing our rise over our run gives us a slope of 2 over 4, which simplifies to 1/2. And then finding the slope of CD, using our rise over our run, gives us the same slope of 2 over 4, which simplifies to 1/2. So now if we take a look at these two different examples and the lines in both of them, since these slopes are the same, these lines are going to go on and on forever in the same direction, rising and running at the same rate. So do you think these lines are ever going to run into each other? No, they're not. But if we look at these, it kind of looks like they might not touch. I mean, they're not touching in this graph. But since the slope is not the same, that means that eventually, if we extended these lines forever, then eventually they're going to run into each other. So, because these slopes are equal, these lines are parallel. So parallel lines have equal slopes. these slopes are not equal, so since these slopes are not equal, all we can say about these lines is that they are not parallel. So these lines are not parallel. Alright, so again, our parallel lines have equal slopes. Alright, if you were paying attention, today is about parallel and perpendicular lines. So now we're going to look at these next two examples and figure something out about perpendicular lines. So here my lines aren't named, so I'm going to just pick some random letters to name them. I'm going to name this one XY. So if I find the slope of XY using my rise, oops, I went up too many, over my run, then I find a slope of XY is 5/8. And then same thing, I'm going to name these points. I'm going to pick M and N. And pick whatever letters you like. And let's do our rise over our run to find that slope. So MN has a negative slope, -11/5. Alright, looking at this next example before we talk about the lines. Again, I'm going to name this first line XY, and I'm going to count its slope as rise over run. So for XY, I get a slope of 9/9, which simplifies to 1. And then I'm going to name this one MN. And same idea, count that rise and that run. So for MN, I get a slope of -9/9, which simplifies to -1. So unlike parallel lines, perpendicular lines are going to touch. In fact, they're going to intersect just like these two lines do here. And we know, even though these are intersecting, we know that these are perpendicular and these are not because of their slopes. So perpendicular lines are going to have what we call opposite reciprocal slopes. So if you just want to make a little note down here, opposite reciprocals, that's how you spell it, opposite reciprocals, are two slopes that are going to have opposite signs, so positive or negative, and a flipped fraction. So some examples of that. Examples of opposite reciprocals could be like 3/2. Since this is positive, my opposite reciprocal needs to be negative, and I flip it 2/3. Or another example, which is kind of like what happened up here. If we have negative, let's say 4/4, well, any number divided by itself just equals 1. And then positive 4/4 is still going to give you 1. But we know that 1 can be written as a fraction just as 1/1. So even though it's the same number, those are still flipped fractions. So I can go up here and say, because the slopes are opposite reciprocals, these lines are perpendicular. And then if we look over here, these slopes are not opposite reciprocals. So these lines are not perpendicular. Alright guys, good job for watching your first flip class video. I hope that it went well.